So we have 9.2 notes. We're going to write this question on the back. Verify the segments with the lengths 14, 15, and 11 form a triangle. Is the triangle acute, right, or obtuse? So first we're going to verify. What do we do to verify that any lengths form a triangle?
Two small numbers are bigger than the biggest number.
Yes, you're going to add the two smaller, and they have to be bigger than the largest side. So here, what are the two smaller? 11 and 14, and obviously 11 plus 14, is that greater than 15? Yes. So it is a triangle. So from here, we're going to decide, is it acute, right, or obtuse? What do we use to figure out what kind of triangle it is? The Pythagorean Theorem. A squared plus b squared, and we're going to compare it to c squared. So c squared is what we'll look at in the end. If c squared is larger, what kind of triangle will it be? Obtuse. And if c squared is smaller, it'll be acute. And what if they equal? It'll be a right triangle. So which of these sides is going to be c? 15, the longest side, which means the other two will be a and b. So what's 11 squared?
129.
And then 14 squared?
196.
Good. And then we're going to compare it to 15 squared, which is
227.
225. I think you did 25 squared. What's 121 plus 196?
317.
317. So again, your hypotenuse squared is what matters. You're going to compare it to the other side. So 225 is smaller than 317. So what kind of triangle is this?
Acute.
It is acute. Okay, acute. All right, so you can flip to the front. You're going to see an acronym at the top. I'm going to explain the purpose of it. You've already learned part of trigonometry. Trigonometry is about triangles, and in specific, we've been talking about right triangles. So let's look at this picture I have here. Notice all the capital letters. What are all the capital letters in this picture? Angles, they will always be capital. And then the lowercase letters represent sides. All right, so let's talk about finding missing sides and angles in a right triangle, because that's literally this whole chapter, is finding missing sides and angles. We already figured out if we were given two sides and we had to find the third, how did we find the third side in a right triangle?
A squared plus b squared equals c squared.
Correct. We used the Pythagorean Theorem. So all of these letters are lowercase in the formula because they're sides. If you have two sides and you need to find the third, use the Pythagorean Theorem. But there are other cases we're going to find angles, or we're going to be given an angle. We can't use the Pythagorean Theorem for anything with an angle. All right, so if you're given a side and an angle, or you're given two sides, to find an angle, we use a trig ratio. There are 3 trig ratios. Trig is shortened for trigonometry, and a ratio is a fraction. So these trig ratios are called sine, cosine, and tangent, and if you notice, they're the name of this section. And we use this acronym SOH CAH TOA to remember each ratio, each fraction, if you will. So first, you're going to write down sine, cosine, and tangent for S, C, and T. Sine, cosine, and tangent. They're the names of the 3 trig ratios. There are actually 6. You'll learn the other 3 in Algebra 2. But sine, cosine, and tangent, they're like the basics. So sine, okay, I'll show you in a picture here in a second. But remember, in this section, you just have to memorize what each of these words stand for. And then I'll explain kind of why. But sine will be a fraction. It'll be the opposite side. So go ahead and put opposite for O. Sine will be the opposite over H, which is the hypotenuse. I'll show you with this picture. Sine is opposite over hypotenuse. And I'll show you with this beautiful triangle here. So sine, when we shorten it, you shorten it to S-I-N. Some of you said you saw it on maps. We don't call this sin. I know it looks like if you read it, but we call it sine. And then you would tell me from what angle. So we would say like from angle R. And what would happen is we would find the fraction with the opposite side over the hypotenuse side. So what is opposite of angle R? Which of these sides is across from angle R? R is across from R. So this would be your opposite. And then, so R is your opposite. And then which of these, because sine is opposite over hypotenuse, which of these is the hypotenuse? S is the hypotenuse. So eventually these will be letters, or these will be numbers instead of letters. So it might, eventually make more sense. But all you're asked to do in this section is know that sine of an angle is opposite side over the hypotenuse side. And we'll use numbers here in a minute. Cosine, ca. People get this one wrong because they call each other ca. I don't know if any of you do. But make sure you spell it right. It is CAH. I'm not kidding. Every year someone spells it wrong. But CAH. A will stand for the adjacent side over the hypotenuse side. So we're going to fill in A stands for adjacent side over the hypotenuse side. Adjacent side over the hypotenuse side. So cosine shortened looks like COS. Again, we call it cosine. We don't say cos because that sounds dumb. But cosine from, we'll say R again, will be the adjacent side over the hypotenuse side. So let's go back to this. Which of these, again, was the opposite side? R was opposite. And which of these is the hypotenuse? S. And then your adjacent side will be Q. And here's why. If you remember, we learned it in 1.3. Adjacent means they share a wall. So my room is adjacent with Miss Dix. My room is also adjacent with Miss Shank. So if you see Q is adjacent with angle R. S is also adjacent, but S is called the hypotenuse. Will the hypotenuse ever change in a right triangle? No, it'll always be the longest side. It'll always be across from a right angle. So in this case, you would do cosine of R is the adjacent side, which is Q, over the hypotenuse side, which is S. So again, one day, like in 5 seconds, these will be numbers instead of letters. The last one is called tangent. So what does O stand for? Opposite. So tangent is opposite over adjacent. So the opposite side over the adjacent side. So we shorten tangent to TAN. We still call it tangent, but when we write it out, we write TAN. From angle R, you would put the opposite side over the adjacent side. So opposite of R is still R. And then what was adjacent to angle R? Q. All right. So we're going to use this. Again, this section, the whole purpose is for you to memorize SOH CAH TOA. And then we'll learn how to apply it and find other things in the next section. So this picture's at the top of your page. It says 6, 8, 10. Everyone locate it? Everyone sees it? It doesn't have a set of directions. You're going to write them down. Find the trig ratios from the smallest acute angle. So this goes with the top picture here. So find the trig ratios from the smallest acute angle. This is what it'll look like on Wednesday. One of your questions will say find the trig ratios from the smallest acute angle. So, from the smallest acute angle, guess which one of these is not an acute angle? The right angle. So C is not the smallest acute angle. The smallest acute angle will be across from the shortest side. So which of these is the shortest side? 6. So what angle is across from that? Angle B. So go ahead and mark that we're going to be looking into this triangle from angle B. So I usually put an arc. Some people like to put an arrow. Here's why this matters. We're using the word opposite, right? Okay. What wall is opposite of you? The front wall, right? What wall is opposite of me? The back wall, because you're faced a different direction. So you need to make sure you know what direction you're looking into the triangle. So when you look at this picture, you want to think that you're standing here at angle B, and you're going to label the sides opposite, and hypotenuse are the easiest ones to label first, and then the adjacent I would just label last. So what is opposite of angle B? 6. Go ahead and label it the opposite side. The other easy one to label, because it will never change, is the hypotenuse. which of these is the hypotenuse? 10. And that means 8 has to be adjacent, which makes sense because it is touching angle B. So there you are. So we're going to find sine, cosine, and tangent from angle B. So you're going to write SIN. From what angle are we looking into this triangle? B. So you have to put what angle you're looking into the triangle or you're not actually solving for anything. And you'll see it more with your calculator tomorrow. Sine from angle B equals your opposite side over your hypotenuse. So what's my opposite side? 6 over my hypotenuse, which is 10. So we would do 6 over 10, but before I write it down as my final answer, these are both even, correct? So we reduce in math when we can. What is 6 over 10 reduced to? 3 over 5, 3/5. So make sure you reduce if you can reduce. That is sine. Cosine, you're going to write COS from angle B. So cosine, we did SO, which was SOH. CAH, which is CAH. So what's my adjacent side? 8, and then my hypotenuse is 10. Again, they're both even, so they reduce to 4 over 5. And then last is tangent. So you're going to write TAN, tan, of angle B. SOH CAH TOA. So you want the opposite side over the adjacent side. So opposite is 6, and the adjacent side is 8. Again, they're both even, so this reduces to 3/4. So, right now we're just memorizing. But what you could do with any one of these equations is solve for angle B. All of them have angle B missing, and literally with 2 buttons in your calculator, you would find the measure of angle B with any of these. So that is like our eventual goal. What else do I want to point out to you? Oh, 3, 4, 5. Those should be numbers that you'll see a lot because it's the most common set of Pythagorean triples. Questions on this problem? Okay. We just practice it until we play Book It. That's the end of the new stuff. We're just going to do it. Write the sine, cosine, and tangent ratios from angle C. So go ahead and mark that we're looking into the triangle from angle C. So which of these is the opposite of angle C? Yeah, BA, AB. We don't know it. We'll find it here in a second. So go ahead and label it your opposite. Which of these is the hypotenuse? 50. And then which of these, the last one's adjacent. So we have a right triangle, right? It is 48. We have a right triangle. We know 2 sides, and we're missing the third side. So how do we find the third side? The Pythagorean Theorem. A squared plus B squared equals C squared. Which of these is C? 50. And then it doesn't matter which one I call A and B. It really, really doesn't. After that, I'm going to say 48 squared, and we could say X squared if you don't want to call it B. Doesn't really matter. What is 48 squared? 2,304. Plus X squared equals 50 squared, which is 2,500. Go and subtract 2,304 on both sides. X squared equals 196. So we will take the square root, and X is 14. So what we just found was that missing side is 14. So once we know that AB is 14, now we can do sine, cosine, and tangent. So we can start with sine, so you're going to write SIN. From what angle? C. So sine is so. So what's my opposite? 14 over my hypotenuse, which is 50. I wrote it here because they're both even again. So what is 14 over 50 reduced to? 7 over 25, correct. So that's sine. Cosine from angle C. So remember cosine is CAH. CAH. So what is adjacent to cosine? 48. And the hypotenuse is 50. They're both even, so this reduces to 24 over 25. And then last is tangent. Tangent of C. So tangent is TOA. So what is the opposite? Over the adjacent, which is 48. Again, they're both even. This will reduce to 7 over 24. So you will be asked to do this on your quiz, like where you need to find the side first and then do sine, cosine, and tangent. I'm going to have you try the next one. It's on the next page, page 2. And then we will check it. So I do not have the laptop on the floor. I just worry about me kicking it or someone else. It looks like we're getting close. All right, so the first thing you had to do was find the missing side. So what did you do to find your length of AB? Pythagorean Theorem. What did we find for the length of AB? 16. Good. So from angle A, what was your opposite? 30. Your hypotenuse? 34. And then your adjacent was 16. Go ahead and check your answers. Here are the reduced versions. Sine of angle A is 15 over 17. Cosine of angle A is 8 over 17. And then tangent of angle A is 15 over 8. So just look at your paper and make sure you had those answers. So out of the 4 questions, 2 of them look like this. That's number 2. 2 of them look like this. So questions on listing them yourself. Okay. Then I'm just going to show you what the bookets will look like, as well as we'll start a worksheet tomorrow. We're going to find the specific trig ratio. So this first one, we're going to find sine of A. So we want sine. Sine is what over what? Opposite over hypotenuse. So from angle A, I need my opposite and my hypotenuse. So what is opposite of angle A? 24. And then my hypotenuse is 30. So it would be 24 over 30. This can be reduced.
12 over 15.
We could do 12 over 15. Is that fully reduced?
4 over 5.
You got to keep going. So it's not wrong, but you would just keep going. It's 4/5 in the end. Sine from angle C. So again, from angle C, we want opposite over the hypotenuse. What is opposite of angle C? 32, and the hypotenuse is 40. So you would do 32 over 40. What are they both divisible by?
8.
You're both right. So if you did 2, you would have to keep doing 2 a couple times. But you could do 8. 32 divided by 8 is 4, and then 40 divided by 8 is 5. So there's sine. Cosine, how do we spell ca? C-A-H. So this one we probably have to label the whole triangle to find the adjacent. But we want cosine from C. Which one is the hypotenuse? 25. Which one is the opposite? 15. So that means the adjacent is 20. So my fraction would look like 20 over 25. This can be reduced. They're both divisible by 5. So we get 4/5. Yeah, 4 or 5. You're going to get other numbers than 4/5. It's just 3. I told you 3, 4, 5 was the most common. Pythagorean triple is just y. Number 4, cosine of A. So which of these is the hypotenuse? 41. Opposite is, so that means 9 is the adjacent. So what is my fraction going to look like? 9 over 41. I did forget to mention this. On the worksheet tomorrow, if you want to write this down, it's going to ask you to round to the nearest 10,000th. 10,000th. All you do is you would type in, like if we wanted to do 9 over 41, you would literally just type in 9 over 41. How many zeros are in the number 10,000? There's 4, so you'd go 4 decimal places. So what is 9 over 41 equal to as a decimal? To 4 decimal places. What is it?
Isn't it 4? Oh, no, wait, I thought.
You did 40.
9.5.
Just 9.5?
2195.
2195, yeah. So on the worksheet tomorrow, it might ask you to make it a decimal. You just type it in, and that's it. So just for you to be prepared for that. We have 2 more, and then we're going to play Look it. Tangent from C. Nice. Tangent is TOA. So we want opposite over adjacent. So what is the hypotenuse in this problem? 34. And the opposite is 30, which means the adjacent is 16. So what's my fraction going to look like? Opposite over adjacent, 30 over 16, which reduces to 15 over 8. I did have someone ask me earlier to make it a mixed number. I would not. You're going to type this into a calculator eventually to solve for angle C. So making it a mixed number is not very helpful with the calculator. The last, number 6, tangent of x. So again, we want opposite over adjacent. What is opposite of x? 8. Hypotenuse is 17. So what is the adjacent? 15. Can this be reduced? Nah. That's it. So we're going to play some Blookets.